welcome to 10.3, where we discuss the volume of spheres. Spheres are found everywhere. A golf ball, a globe, a baseball, a softball, a wiffle ball, a volleyball, a basketball, a tennis ball. I could go on and on and on.
A clock.
A clock. The clock's not really a sphere, Morgan. Sorry, that's a circle. All right, so let's talk about our learning target for today. Our learning target is to find the volume of a sphere. Our success criteria will be measured by our ability to use a formula to find the volume of a sphere, use the formula for the volume of a sphere to find the radius, and find the volumes of composite solids. So let's dive right in. A sphere is a set of all points in space that are the same distance from a point called the center. The radius r is the distance from the center to any point on the sphere. A sphere is different from the other solids you've studied so far because it does not have a base. If you think about a softball or a baseball or a basketball, they don't have a base. It doesn't matter where you grab them, they're always kind of the same. Okay? So let's dive on into 10.3. Key idea. Volume of a sphere. The volume of a sphere is the product of 4/3 pi and the cube of the radius of the sphere. So in algebra, that looks like volume, or V, is equal to 4/3 pi r cubed. Okay? Radius cubed. So let's go into finding the volume of spheres. It wants us to find the volume of each sphere and round our answer to the nearest tenth. So for A, we have a sphere and it has a radius of 4 centimeters. So we're just going to plug it in. We're going to say 4/3 pi times 4 cubed. Okay? And then we're going to go and we're going to do some math. And I think I'm going to break away from this over here a little bit, and I'm just going to kind of branch out. I'm going to say 4 cubed is 64. So I have 4/3 times 64 times pi, because I can use the commutative property to move things around. And then I'm going to say that 64 times 4 is 256 over 3 times pi. And that, my friends, is where this part right here comes from. And then for this part, I'm just going to use a calculator. I'm going to enter parentheses 256 divided by 3 end parentheses times pi. And I'm going to get that is approximately equal to 268.1. Yes, in a minute, buddy. Sorry, guys. So that's approximate because it's actually 268.08. We're going to round it to the nearest tenth, as it tells us to do right here. So it's approximately 268.1 cubic centimeters. Remember that we did this to the third power, so it's centimeters cubed. Okay? Let's look at B. B has a radius of, well, it has a diameter. For B, our diameter is equal to 10, which means our radius is equal to 5. So we're going to say volume is equal to 4/3 pi 5 cubed. Now 5 cubed is 125. So 4/3 times 125 over 1 times pi. So 125 times 4 is 500. So 500 over 3 pi. And again, I'm going to use a calculator. I'm going to enter parentheses 500 divided by 3 times pi. Hold on, I entered something wrong. 500 divided by 3 times pi. And that gives me approximately 523.6. Here we are dealing with feet cubed. Okay, so this is really all just about plugging things into a formula. And I think if we come back up here, we will see, let's see. It doesn't. Honestly, I'm gonna be real with you guys because you know that's how I am. The material that I used last year to teach volume of cylinders, cubes, and cones, which is what we've done 10.1, 10.2, 10.3. The stuff I used last year was actually a lot better because it explained to you that a cylinder, how a cylinder and a cone relate to a cube. And I kind of missed that because it did a really good job about it. So let's do the try it. Sorry, my tangent. Let's do the try it. It wants us to find the volume of the sphere. So in number 1, we're going to have 4/3 pi. The radius here is 2 cubed. So 2 cubed is 8. So 4/3 times 8/1 times pi. 8 times 4 is 24. So 24/3 times pi. Plug it into the calculator. I keep going too fast and hitting the wrong button for pi. Instead, I'm hitting E. Not the same answer. And so for this one, I am getting 25.1. I'm opening my book. I haven't even opened my book yet to see if my answer is correct. So if you got the same answer I did, I'm getting approximately 25.1 millimeters cubed. Then you probably got it right. Oh, I didn't. What did I do? What did I do wrong? This one says 32/3. Did I multiply wrong? Is 8 times 4 not 24? 8 times 4 is not 24. Guys, this is why I need to be in class with you guys, because somebody would have stopped me and told me, it's screwy. 8 times 3 is 24. 8 times 4 is 32. But we're not in class together because we're social distancing. So 32/3 pi, which is going to give me a completely different answer. It gives me 33.5, which is what my book says. 33.5 millimeters cubed. Glad I checked the book. Man. Oh well, mistakes allow thinking to happen. Now I know I need to check my math sometimes, right? Well, we already all knew that because I make mistakes like that in class all the time. All right, let's look at number 2. Number 2, we have a diameter of 16, which means our radius is equal to 8. So we're going to have 4/3 pi 8 cubed. 8 cubed is 512. So we're going to have 4/3 times 512/1 times pi. I don't know why I wrote an equal sign right there. Okay. So I'm going to see first if 512, if I can cross reduce. I can't. So 512 times 4 is going to give me 2,048 divided by 3 times pi. So let's plug that in to the trusty calculator. And I get 2,100, approximately 2,144.7 feet cubed. So, hold on. I'm trying to pause so I can put lotion on my son, but it's not working. Buddy, can mommy put lotion on you in just a minute so I can finish this video? No. Go ask sister to put lotion on. Sorry, guys. All right, let's go on to example 2, finding the radius of the sphere. So in this one, they're going to give us the volume, and we're going to have to work backwards to find the radius, okay? So we know here that our formula is volume equals 4/3 pi r cubed. So we're going to fill in the information that we know. In this one, we know that the volume is equal to 288 pi. So they left this in terms of pi. So we know that 288 pi is equal to 4/3 pi r cubed, okay? And then what we're going to do is we're going to use the multiplicative property of equality, and we are going to multiply both sides by 3/4, and we're going to, okay, how can I explain this? If I had this as 4/3 times pi over 1, then it would be 4 pi over 3. And so in order to undo that multiplication, we use division, which means we multiply by the reciprocal. So I'm going to multiply by 3/4 pi to each side. So over here, 3 times, not what I'm writing. I'm going to multiply it by 3/4 pi. And I'm going to do the same thing over here. And what that does is these all cancel each other out, okay? And then on this side, I'm left on this side over here, okay? The pi's are going to cancel each other out. And then I'm going to have 3/4 times 288, which is 216 equals what's left over here, which is my r cubed. Okay? Now, in order to get r, I have to find the cubed root, because remember, cubing and finding the cube root undo each other, just like squaring and square rooting undo each other. So I'm going to find the cubed root here and the cubed root here, and that means these are going to cancel, and I'm going to find the cubed root of 216. Now, if you're using a graphing calculator, the best way, because this gets into like log and dealing with logarithms, which is how it actually makes it easier, the best way that I'm going to advise you guys to do it is to just kind of do a guess and check, okay? We know that 4 cubed is 64, 5 cubed is 125, so let's try 6 cubed, and 6 cubed is 216, so our r equals 6. And in this case, we're talking about inches. Now, I know that looks like a lot, but just keep in mind how we solve problems with fractions. So what I want to do really fast is I'm going to kind of erase all of this, and I'm going to show you how I kind of think about this when I'm doing problems where they've left the answer in terms of pi, okay? Now, to me, when I see a problem that has the answer left in terms of pi, and I have pi in my problem, so we left it, whoa, I don't even know what happened there. Sorry about that. Okay. So we have 288 pi equals 4/3 pi r cubed. Because my answer is left in terms of pi, that means they didn't simplify it out. They didn't solve it out. They just kind of left pi as a simplified version. So what I tend to do when I'm working with this is I just cross pi out of the whole thing and know that my answer is going to work out because they just kind of didn't solve that part of it, if that makes sense. So basically what I'm left with then is 288 equals 4/3 r cubed. I want to get the r by itself. So I know that to get the r by itself, I have to multiply by the reciprocal. So I multiply by 3/4. Okay, and this just kind of makes it a whole lot simpler. I don't have to deal with that whole like pi thing. I do the same thing. 3/4 of 288 is 216 equals r cubed. I still have to cube root it. And I still get that r equals 6. And you can kind of see that crossing out that pi up at the very top in that very first step didn't affect my answer at all. And that's really because when you solved this, when they got this 288 pi, they didn't simplify pi. They didn't do 288 times 3.14. They didn't do 288 times pi on the calculator. They just left it as pi. So because they cancel it out right here in this step anyway, I find it easier to just kind of cancel it out in this step up here. And I might be teaching you something totally wrong, but that process has never failed me yet. So You guys know I'm all about working smarter, not harder, and finding ways that make sense. And that makes sense to me. So let's go ahead and let's look at try it number 1. I want you to pause this and do try it number 1. And then when you come back, we'll solve it together. I guess it's try it number 3. Whatevs. Okay. So our formula is volume equals 4/3 pi r cubed. And this one, they gave us the volume again. They gave it to us as 36 pi. So we're going to say 36 pi equals 4/3 pi r cubed. And I'm going to do my method. I'm just going to forget about the pi. Since they solved it in terms of pi, I'm just going to forget about it. And I'm going to rewrite this as 36 4/3 r cubed multiplied by the reciprocal so that these cancel. Multiply by the reciprocal, okay? 36 is divisible by 4, it's 9. So 1, 9, 3 times 9 is 27. So 27 equals r cubed. If you go back and look at a cubed root table, a cube table, whatever have you, you know that you have to cube root this. The cubed root of 27 is 3. So r equals 3 meters. And again, you can see I skipped that whole part with the pi because they didn't solve it for pi. They didn't multiply it out by pi. So the pi just kind of becomes a non-essential. Okay? So I think of it as because there's pi on each side, I don't have to worry about pi. Let's look at number 4. And that, guys, really that only works if there's pi on both sides when you're solving for volume. Okay? So for instance, when we look at number 4, they give me that the volume is 14 inches. So V equals 4/3 pi r cubed. This is my formula. They tell me here that the volume is straight up 14. No pi. That means they solved it in terms of pi. So that means on this one, I have to multiply by pi. Okay, I have to keep the pi in on this one because this 14 right here is just 14. It's not 14 pi. So I'm going to multiply by 3/4 pi because that's the reciprocal of that. So 3/4 pi. Okay, so 3 times 14 is going to give me 42/4 pi. And I'm going to leave it like that, equals r cubed. And then I'm going to plug this part right here into the calculator, okay? So I'm going to do 42 divided by parentheses 4 pi. And I get 3.3, I'm going to leave it as 3.34. And then I have to find the cubed root of that. And I'm trying to find on this calculator if it has, I swear I did this the other day and found like a cubed root function. Maybe not. Let me try something. I keep hitting the wrong button. That's not the right button either. Sorry, guys. You know I do the same thing in class sometimes. When I don't know how to do a problem and I sit here and try to figure it out. Okay, we're going to try something else. Watch this. We're going to pop over here. We're going to go to Desmos. We're going to see if Desmos has it. Because I know what the answer is, but it doesn't do me any good. So I'm going to type in equal cube root. No? No? I don't know. Let's just type in cubed. I can spell. Cubed root of, what was our thing over here? 3.34. sometimes good old Google just comes in for you, right? Sometimes you just gotta Google it. And you get 1.5. If we rounded it 1.5, which luckily for Miss Cruey is the answer, it's approximately 1.5. So sometimes you just gotta Google it. Sometimes you gotta use your expertise in other areas. I'm still looking at this calculator, looking to see if it has a cubed root function. And I know there's going to be a math teacher out there somewhere who watches this video and they teach like Traeger Algebra 2 and they're telling me to use logarithms. And I'm going to be perfectly honest. I did logarithms in high school, but I haven't done logarithms since then and I can't remember how to do it. I know that there's some log E and you can use that to do the root of any root, but I don't remember how to do it. So we use Google. Sue me. Actually, don't. Please don't. Anyway, this is 1.5 inches. All right. Moving on. Moving right along. Moving right along. Modeling real life. It says a hemisphere is one half of a sphere. The top of a silo is a hemisphere with a radius of 12. What is the volume of the silo? Round your answer to the nearest thousandth. So we have two different things going on here. We have a cylinder. This part right here is a cylinder. The bottom half of the silo is a cylinder. And then we have the hemisphere on top. Okay? So we are asked to find the volume of the silo. So we're going to break the problem into parts. First, we're going to find the volume of the cylinder. And then we're going to find the volume of the hemisphere. And then add those two together. Okay? So when we're finding the volume of a cylinder, volume of a cylinder is really easy. Volume equals base times height, right? Area of the base times height. Sorry, area of the base times height. So volume equals area of the base times height. Okay? The area of the base here is a circle. It is a circle. Okay? And we know that because it's got a circle sitting on top of it, essentially. And we know that the radius of that is 12. So for the area of a circle, remember it's pi r squared times height here. This pi r squared is the area of the base, okay? So we're going to have pi times 12 squared times the height of our silo here, which is not actually 52. You look at this and you see that 52 there, but you have to keep in mind that the top part of the cylinder has that same height of 12. So 52 minus 12 is 40. So the height here is 40. You plug that all into a calculator, and they just left it in terms of pi. So they left it as 5,760 pi. Okay? So that is the area, that's the volume of our cylinder. Now we need to find the volume of our hemisphere. Hema means half, so it's half of a sphere. So we're going to use our volume for sphere and divide it by 2. I'm going to make this, so volume equals 4/3 pi r cubed divided by 2. So 4/3 pi times 12 cubed divided by 2. Not 12, 2. 2. Okay. They did it times 1/2. Doesn't make a difference. Divided by 2 times a half, same exact thing, right? 8 divided by 2 is 4. 8 times a half is 4. Multiplying by a half and dividing by 2 are the same thing. So, 12 cubed, let's start there. Trusty calculator. 12 cubed is 1,728 times 4/3 is 2,304. Divide that by 2, and we get 1152 pi. Now you notice nowhere in there did I multiply by pi. I left my answer in terms of pi. Okay? Because I'm going to add this one and this one together, it's easier to leave them in terms of pi now. So I'm going to add that 1152 plus the 5,760, and I get 6,912, and it's still in pi. So 6,912. Now I'm going to take it out of pi. Now I'm going to, if you look back up here, that's what they got. And so now I'm going to take it out of pi, and I'm actually going to multiply that 6,912 times pi, and I get 21,714. 21,714.7. Now let's go back up and look, because it wants us to round our answer to the nearest thousand. Notice it's thousand, not thousandth. Thousand. So that means it wants it basically as the nearest whole number to the thousand place. So when we look at this is 21,714. This 700 right here, 700 tells me that I'm going to round my 1 up to a 2. So this is 22,000 pounds is the volume of the silo. Pretty cool. Okay, I know that was a lot of work. Okay, so go do your homework. No homework for you guys on Monday. Monday for this week, this year. I don't know. Like, obviously, all of you are using this video this year, but I don't know if I'll use this video in a future year. Probably not, because I don't think I'm using this material next year. But anyway, Monday, April 13th, 2020, in the middle of the corona crisis, there is no school for Mountain Vista. It is Easter Monday, and we will have no school on Monday. So I will not be posting a video, and I will not be posting a homework assignment. All right, guys, have a good day, and I miss you all.